Good evening from Slovakia. I will do a small introduction. At the beginning, I'm very sorry for the technical problems from the Zoom application, but now we are okay, we can see us. It was interesting because on two links was more than 100 people together. So on one link were some people, another one also some. So I don't know where the problem is, but we will manage this. So once more, good evening. Thank you that you came to this first presentation of the series of our lectures, which are devoted to the fascinating phenomenon of the karst and caves. And this cycle will gradually introduce various general and regional topics on a monthly basis. This activity is dedicated to the support of the International Year of Caves and Karst, which was announced by US for this year, 2021. During the lectures, not only various topics will be alternated, but also the personalities of the speleology and karstology. And we will try to keep the alternation of the languages also. So today we will start with the English, and the next will be in the Slovak language. At the same time, these webinars will take place under the auspices of the Institute of Geography of the University of Pavel Jozef Šafárik in Košice, and also the Slovak Geographical Society. I'm honored to introduce you our guest for today, Ged Campion, who is certainly the most qualified to open this lecture series. So many of you know him as the president of the European Speleological Federation and as a very active caver and climber. And during this online seminar, Ged will introduce us to the Yorkshire Dales and Ingleborough karst as one of the most important karst regions in Great Britain. Of course, this region is still has still many undiscovered secrets, so we will see today. Personally, I am very excited to hear some information about it. During this lecture, you can also ask questions using Padlet website. This link will be listed below in this video in the description. I will do it in a few seconds because we changed to another link, so I need to change it also. Please feel free to send some questions, and after the presentation, Ged will try to answer as many questions as possible. So we will start with this that seems to be the most interesting and relevant to you and have the most number of likes. After all main informations, something about me, who I am. My name is Alena Gesert. I work on the mentioned Institute of Geography, and I'm a leader of the Košice branch of the Slovak Geographical Society. At the same time, I'm also General Secretary of the European Speleological Federation. So Ged is one of my bosses in work in the federation. So I hope he will be satisfied with me today, but it's not very good. So I'm really sorry for this again. And I think we can start sharing your screen, Ged. So I will be here. We are not able to read your questions in the chat of the YouTube. I'm sorry for this. So for these questions, I will post now a Padlet website, and also I will put it into the description of the video for later if you want. So have fun and nice evening.
Hello, everybody. And first of all, thank you, Alena, for giving me this opportunity to give this webinar today. Now, I'm going to talk about my caving club and other cavers' search for an underground river below the slopes of Ingleborough Mountain in the Yorkshire Dales. You'll see a picture of Ingleborough there on the screen in front of you. What I'm going to do is discuss some of the techniques that we've used to support our exploration, And I'm also going to comment on the landscape and geology of the Yorkshire Dales. It's been a long-held belief that a master cave or major cave system or a collector or a mainstream passage or whatever you would call it does exist beneath Newby Moss. But obviously it's never been entered because of obstacles that have been encountered by cavers. The title, The Lost River of Ingleborough, is borrowed from a colleague's article in Descent, a British caving magazine, and that colleague is Frank Pearson, but I hope he doesn't mind me using that title. Now, throughout the presentation, I'm going to use a number of diagrams, maps, and images, which aren't always mine. Many of them are my son, who is Ged Campion, and he completed some research on the area as part of his university studies in physical geography and geology. Unfortunately, he can't be available. Just to let you know, I'm a member of a local caving club, the Yorkshire Ramblers Club, who have been around since 1892, and they've been exploring Newby Moss for many decades, along with other clubs and individuals. Okay then, so the first slide we're going to look at, you will see there on the left a slide of the north of England. Many of you will know this location, but for those who don't, we have the Pennines, which runs right down the backbone of this part of the UK. And over on the left there, we have the Lake District. These are other cities people will know about. So if we zoom into the site of location, you can see on the right there, we're talking about Ingleborough Mountain. And this mountain, as you can see, is over 700 meters in height, and surrounding it is the important stuff, the limestone, the carbonate that contains the caves. And you will see that that red highlight is the Newby Moss area, which we are going to concentrate on looking at. So the Yorkshire Dales is an area of around 2,000 square kilometers, and it's a national park, and it's very often visited by tourists. And there again, on this slide, we're zooming in even closer to Ingleborough and Newby Moss. So you'll see in the center of your screen there, the center of the red outline, Newby Moss. And you'll notice from this Ordnance Survey maps, there's many potholes listed. Potholes are what we call vertical caves in the UK that are usually entered via ladders or ropes and that sort of thing. And you'll see down to the right there, a village where there's a lake by a church. That is really the area that is where the resurgence is for the water that goes into the potholes comes out at the bottom. But we'll talk about that in more detail in a moment. So the Yorkshire Dales is known very, very much for its spectacular karst scenery. And there are some images of glacier karst. Malham Cove on the left there is a huge amphitheatre, nearly 80 meters high, of vertical walls, and is a product of the melting glaciers around the time of the Devensian cycle and even before that. And there in the center, you can see Trow Gill, which again is eroded gorge from the meltwater that would have been colossal when the glaciers were retreated. And again on the right, you've got Gordal Scar, another famous landmark that again is a canyon or a gorge that's been eroded by melting glaciers. And Clints and Grikes, a very famous and well-known spectacle in the Yorkshire Dales. On the left, that's the top of Malham Cove, that huge amphitheatre that we were looking at a few minutes ago. And there on the right, you can see Ingleborough Mountain on the left. So these are the Clints and Grikes. I won't go into the detail of how these are formed. There wouldn't be time in this particular webinar, but they are fascinating and interesting parts of our landscape in the Yorkshire Dales. And then, of course, we have the sinkholes or potholes, and most famously, perhaps, is Gaping Gill, which is a very deep cave pothole, one of our deepest pothole or sinkholes, which is over 100 meters in depth and takes a major stream or river, as you can see there on the left. The cavern on the right is at the bottom of where that stream lands, and I don't think that slide really gives it a full impression of the size of that cavern, but that is a huge cavern. And they say that you could fit St. Paul's Cathedral from London in there to give you a sense of the scale. So there are many of these sinkholes in the Yorkshire Dales where the water disappears high up on the mountainsides. So here we have a map that I've borrowed from Tony Waltham, one of our top geologists on Ingleborough. There are many others, but this is one of his maps. And you will see the circled area is Newby Moss, and that's what we're going to concentrate on today. But it's important to look at the whole of the mountain there. In the center, you have the Massif of Ingleborough. But all around it, you have limestone pavements or benches or plateaus that we would call, that are at around a 400-meter level, which is fairly consistent in this area. And it's on those benches that we get the caves where the streams sink. And on the west and east sides, they're quite prominent, the pavements. But you will note in the south, where we've got Newby Moss, they are not so prominent. There's not such a strong exposure of limestone there. And this is because the glaciers that came from the north and traveled southwards would often scour the levels and expose the limestone. But because Newby Moss area is in the lee, the protected lee of Ingleborough, it would have left an awful lot of glacial till or drift to cover that area. And this has been one of the problems in terms of trying to actually find out how to enter this mystical master cave that we're looking for. But you can see there the center of Ingleborough is not carbonate, is not limestone. It's made up of many different types of geology, geological succession that we'll talk about in a moment. And it's interesting that a lot of the caves in the Yorkshire Dales do drain in different directions. What we call the Vados caves, the younger caves, tend to drain towards the northeast, whereas the larger, what we call phreatic caves, the phreatic tubes that are often filled full of water, often drain towards the south, where they travel towards their resurgences. So it can be quite a complex hydrology that we look at as we try to understand how the mountain works. And then there is a picture of Ingleborough Hill on the left. I'm sorry for the quality of some of these slides, but you will see the limestone benches there in below the slopes of Ingleborough, the grikes and the grikes and the pavements that we were talking about, the clints and grikes. And you will see that they are well exposed there at that 400-meter level. The mountain itself, as I say, is 700 meters high and of a different type of rock. And then on the right there, we've got a picture of Newby Moss. And you will see straight away, we're looking from the south, and there is an awful lot of glacial till covering the limestone. That is a cave entrance there, Lonkin West, that we're looking at. And you can see the exposure of the limestone in the entrance, but there are masses of areas where you can't see this because of the depth of the till. And then if we look at the resurgences, this is where the water that disappears into the pothole actually comes out almost 4 kilometers away. We have some very important outflows. On the left there, we have Clapham Beckhead that's delivering something like 50 liters per second. And then on the right, a very important resurgence that we're going to look at today is Moses Well, far less known than the one on the left, and that's on average issuing something like 10 liters per second. But this is the most important resurgence of the Newby Moss area that is the subject of this delivery today. And there are other springs and resurgences that we will mention. This one here is Catholes, and this we believe is an overflow of that previous slide of Moses Well. that doesn't always issue much water except during flood conditions. And the slide on the right, I think, illustrates that fairly well. Very turbid brown water is issued from that resurgence in times of flood, which would indicate glacial material, we hope, in a much larger cave beyond that entrance. So if we start to look at the geology of this area, we can see there are numerous faults and different types of rock. So again, at the top of the slide, we've got the slopes of Ingleborough, and we'll talk about what that will be in a moment. And you can see that important shale margin where there's a line of sinkholes, and that's where most of the potholes and the sinkholes that we're dealing with actually have the sinking streams. And then at the bottom right hand of the slide, you'll see Cat Hole, Moses Well, where the resurgences are. So broadly, there's something like a distance of 4 kilometers from sink to resurgence, which would suggest quite a large system underneath this part of the limestone, and various faults which obviously influence the direction of caves. And we've found that in this area, faults do seem to go mostly from west to east quite consistently, which does give us indications of where caves might be, because caves are very much influenced by faults. The water will obviously travel through joints and bedding in the limestone, but if it finds a fault, it would be very attracted to that and flow through that. And this is where you can find some very large caves. Okay, so if you look at that red section going through the map, we'll now look at a geological cross section that will help us understand the geology in more detail. Now, as we look at this cross section, I must tell you first of all that Silurian is spelt incorrectly down on the legend at the bottom there. And don't worry too much about Silurian at this stage. What we need to really concentrate on is that this rock here, this is the basement rock. And this basement rock is generally of Ordovician age. So that would have been laid something like 400 to 500 million years ago. And then the period after that, there was an awful lot of erosion before the limestone, the carbonate, overlain that. So that's what we would call here, there is a major unconformity between these two layers of rock. And higher up here, we have what we call the Yoredale series. Again, a local name captured from many of the Viking names that we have in this area because they inhabited this area for many years. And then we have this is an alternating succession of shales, limestones, sandstones that isn't obviously so cave bearing. And then, well, not at all in this area, in fact. And then at the top, we have this impermeable, almost impermeable base of gritty, pebbly sandstone of Ingleborough that has been quite resistant to erosion. And that's why it's there, obviously. And then we notice these faults here. We have the North Craven fault here and the South Craven fault here. So we can see straight away there's been quite a massive down throw during one of the periods that has basically influenced the area massively. And here over on the Clapham side, this is mostly millstone grit and continues that way a long way to the south. But our caves here, as you can see, this is just an example of a sinkhole and how the cave is going down to the basement rock. And the basement rock does determine the level at which the caves sink to. This is an impermeable base, this lower Paleozoic rock, so the water cannot invade that area. And then we've got Moses Well, which we talked about, one of the resurgences, and Cat Hole also there. This is perhaps a very simplistic map, and obviously some of you who've mapped this area will probably want to talk to me about some of the detail. And here we have Newby Moss, and on there you've got the glacial till, which covers that area. So a few things to note. This unconformity is very well known and quite a textbook example of an unconformity. Here you can see it. You can see this is in the Horton in Ribblesdale, quite close to where we are. Here you can see the top of the Ordovician rock, the lower Paleozoic rock, overlain by almost near horizontal beds of limestone. But this limestone actually does generally dip 2 degrees or so to the northeast, and different beds of limestone above. And just going back to that slide previously, this area here, this basement rock, is perched on what we call the Ascreek block, which is a huge, slightly tilted block that was raised during a mountain building episode a long time ago, and then slowly tilted. And again, is very much has been an influence. And some people say it is still tectonically moving, which is interesting. And then moving on to a typical Yorkshire Dales cave. A lot of people will know what one looks like. For those who don't, again, a very simplistic slide showing you detail about a typical Yorkshire pothole or sinkhole. As you can say, almost a staircase type of elevation down into an ultimate resurgence here. And some other features here that we would talk about: this very exaggerated washed out shale bed you find in the succession often, and that will determine of the development of the cave in terms of its direction. Here also we have a truncated, very old relic cave passage. And of course, it's interesting that as glaciers melted during the Divensian period and before that, they would not only accelerate the development of caves, but they would also be destructive. And as the ice slowly lowered the valley, the levels of the valley, it incised the valley, it would often cut off these very much older caves, revealing, and through the rejuvenation would find a new level. I doubt if this erosion would have taken place here, by the way. That's probably not ideal, but it gives you some of the major indications of what a typical Yorkshire Dale. Okay, we won't talk about developing inception horizon. That's a very complicated business, way above my pay grade at the moment. But we can see here that we've got these subsidence dolines blocked often by boulders and glacial debris. And this is where the caver struggles to excavate to get through to find caves below. And again, the basement rock below, which is impermeable, as I've already said. So if we go on to the next slide, just so you know, in terms of the type of sinking streams we're talking about, most of the Dales caves are what we call allogenic recharge, that they're fed by very strong sinking streams straight down to their resurgences. But equally, it's important to remember autogenic recharge is important as well. And that's through percolation of waters, often from the soils and the drift above, that work their way down very gradually to influence caves. And many people will know that formations we find are often influenced by these percolations from the surface. So then we are going to look here at an example of a cave that we found a number of years ago on Newby Moss. This one we developed to around 130 meters in depth, which is quite significant in the Yorkshire Dales. Not so much in the alpine regions of Austria maybe, and Switzerland and France, but very significant depth in the Yorkshire Dales. And you'll see there that we have a very large fault. I was talking about how faults influence the direction of caves. And also we can see that the smaller passage down numerous drops through the joints and into larger passage. This cave, this particular one, was very, very much dictated by a fault. And terminated in a boulder choke just down here. That's a passage filled with boulders. There was also a sump that has been dived, but so far it's only been dived for 50 meters, and we're still trying to find a cave diver who will go back in there and dive it beyond that. So this is a virgin sump, almost still in need of diving. So this is a typical survey that we will have done of that cave. And then to find these sort of caves, this is some images of what it's like. It can be quite an operation, as you can see there. My club, for example, between the First and Second World Wars, found many new passage in caves because all the caves are open, and they were shafts on Newby Moss and other areas of the Dales. But nowadays, you have to really work hard to find new caves, and it is only for those dedicated individuals. Here you'll see we've used scaffold to open up this particular cave. You get some very dubious people digging in caves, as you will see here, these sort of characters. This was before the lockdown, when you could have a haircut, but as you can see. So quite a hard business. And it doesn't get better sometimes. This was the entrance to that particular cave, just below the scaffold that you've just seen. This chap isn't stuck, he's just trying to fill this bucket full of very glutinous mud. He looks like he's not unhappy with that facial expression, but he is enjoying himself, as many people have to be in these conditions. And there are some rewards. This is Seeley's fault that I showed you in that previous survey, a huge fault, just more than 30 meters down from the entrance that we broke into, that I mentioned again earlier. And formations you find, this isn't the best example of speleothems, but you can find some very beautiful features in our caves in the Yorkshire Dales. And again, back to the survey, at the very end here, there is a howling draft, a wind blowing through that does indicate that the passage continues, but we've been unable to exploit it because of a boulder choke there. And this is a picture of this boulder choke. We have worked on it, but it's quite a spooky place with very loose boulders. Again, this guy, he doesn't look like he's enjoying it, and it's probably not surprising with all of that around him. No wonder he retired from caving a few years ago. And yeah, scientists and other individuals alike have been very interesting in the area. This is a dowsing diagram that was done. Whether you believe whether dowsing really does demonstrate water underground or not, it's interesting that John Wilcock, as far back as 1991, found indications in his research of large amounts of flow from Lonkin West on Newby Moss all the way down here to these resurgences. And this is a map here that we're looking at that shows us what we do already know about Newby Moss. Lonkin West is a very popular, well-known pothole. And we know, because we've had it tested with artificial tracer, that it does definitely resurge all the way down here at Moses Well. So we're talking about a possibility of a master cave or a large collector, something like 4 kilometers long from here to here. And with an elevation, a drop of something like 240 meters, which would make it the deepest elevation in the Yorkshire Dales if we were able to join up these 2 points and traverse this cave system. Other potholes obviously draining here. You can see these are proved connections, Hernal Moss Pot to Clapham Beck Head, Gaping Gill, the very, very iconic cave resurging at Clapham Beck Head. We know this because they've been tested, but there are many that we don't know, or certainly didn't know until we conducted this recent research. And again, the Craven faults are here, as you can see, and this lake is suspended in this down throw of the limestone. So what we did, or what my son did mostly, he should take credit for this. He did an audit of sinking streams on at Lonkin West. Obviously the ones that were well known are mentioned here again. If we look at Lonkin West, We know that we had positive tests back in as early as 1951 and later in 1971. And we know that there is a connection, a hydrological connection. Again here, different tests were conducted, some with tracers like fluorescein, some with tracers like the CAFOR here, very different methods. But what this did, it highlighted which ones were unknown, and as you can see them there: Fluted Holes, Grey Wife, Vernal Ridge Sink, and Newby Moss Cave, the one we've just been looking at in terms of the survey, P2A, and so on. And then looking on the map here, we see on the diagram rather, we can see where they are sited, and we can see where we have the resurgence down here. So it's about testing these to these resurgences. And I have to mention at this point, there are many other springs in the area. We just looked at the major springs, or he just looked at the major springs. Newbycote Spring takes quite a lot of water, so that was included. But there are many springs in the woods down here in this area that do obviously issue water from the high fells. So the particular method that we used in terms of artificial tracing was fluorescein, and many will be familiar with this technique. So this is sodium fluorescein, a very, very easy to use agent that is injected into the sinking stream. And the way in which we pick up traces of this is through what we call these fluorocaptors here. And in here we use activated carbon, which is very, very absorbent and will easily absorb traces that are in the waters. And this here is just a very tight mesh. This is, I think, a stocking or a woman's tights that can be used very easily. Anything you can find in your partner's underwear drawer, possibly. And it's very important here to label what you're doing so you know where it's going. And it's very important to tie this off in the resurgence so it doesn't disappear when you get flood conditions. And it probably goes without saying, it's so important that when you're doing these tests, the person putting the fluorescein in at the top end isn't the same person that's doing the collecting down here. It's very easy to get cross-contamination if you did that. So basically, why we're doing it like this is fluorescein is expensive. We don't want visual pollution for landowners or anybody else in the valley areas, which would be very upsetting if we turned Ingleborough Lake green or the cows started issuing green milk. This would be a problem. So we have to be sensible how we do this stuff. And then once we've collected the fluorocaptors, we have a chemistry session whereby we have to know how to persuade the activated carbon to show its traces of fluorescein. And this is, I'll go through it very quickly because it can be quite tedious. But first of all, you have to wash your samples. Unfortunately, cave waters do pick up many different organic debris, and some of these can be distracting and can carry and are of similar wavelength actually to sodium fluorescein, which can be quite difficult, which we will mention later, to divide. So the elutant is basically put in this deionized water. We use alcohol and a mixture of the two. We use potassium hydroxide flakes that are then dissolved into that mixture above, and add grams of charcoal sap from the fluorocaptor you've just seen to the 20 mils of elutant in a Pyrex beaker. And then we heat this on a hot plate. You have to be careful because remember it's an alcohol solution, and we allow it to boil for 1 minute, and then we look at it in a subdued light. And much of this research has been done by members of the BCRA, Paul Hardwick in this particular case, and many people before him. And the solution is obviously kept in darkness, so we don't get photo decay, and observed at 15-minute intervals by using a LED torch at 90 degrees to find evidence of traces. So that's an example there of the eluting having been done from fluted holes to the 4 resurgences that we've been talking about. So as you would find in cat holes, it doesn't flow very often, it's an overflow. So we would have expected the carbon not to release hardly anything. In fact, it's just still water that's probably been lying in the entrance for some time. In Clapham-Beck Head, we can definitely see some coloration, and we can see for the trained eye some indication of artificial tracer there, but also we can see brown traces. This is most likely to be tannine in the peat deposits that can be obviously in the water. And when we think of the through flow from the Gaping Gill system, it's very fast, and we will get a lot of peat deposits. Newbycote Rising, some indications of tracer there as well, but in Moses Well, a very strong indication of Fluorescein, suggesting a very strong link. And just to remind you, so this is fluted holes up here. We'll have travelled all the way down here to Moses Well, where we had that very strong coloration. Traces also appeared in Clapham-Beck Head, and also over here in Newbycote Spring. So, but very little, none at all in cat holes, because it wasn't flowing at that time. So if we go back to that again, very important to see those results there. And at the same time as doing these tests, my son Aaron was also looking at the top of, if we sit at the top, we're also looking at other measurements of the water in the caves. We're looking at conductivity, temperature, pH levels, and certainly this is just the resurgences here. So we were finding the water entering the caves at the shale margin as being quite high temperatures because it was summer, but when they emerge at the cave, they would be a lot cooler, as you can see, often around 11 to 12 degrees. And the conductivity was very low at the shale margin, incredibly low, but very high in the resurgences. And again, the pH will be very low in the sinking streams, but extremely, well, not extremely high, but high in the resurgences. And I'm not going to really offer much of an opinion about how much this could tell us about the dissolution of the limestone in the caves. All we can tell from that is there is a considerable amount of limestone dissolution, because these acidic streams coming off the shale margins are obviously in very close contact with the host rock, and dissolution is occurring. And these are just pictures of taking some of those readings. But importantly, back to the water tracing, the dye tracing exercise that we were looking at. And there we've got a results table of what we were looking at. We talked about fluted holes, very positive in Moses Well, and a lot of these others were obviously very positive there. Pillar holes, extremely positive at Moses Well. So these of particular interest to me, pillar holes and fluted hole, and the P2A and P2B, very interesting in terms of where they're located on the fell. So if we go on to the next slide, what does this tell us in terms of the flow regime? Well, straight away we can see pillar holes obviously is, as we said, going straight to Moses Well. We haven't got Lunkin West here. We've omitted that and a number of other potholes for simplicity's sake, really. So these are the ones that we tested. And what is interesting about this? Well, we can see how much this flow regime may be influenced by the Clapdale fault here. And this may be something that really, I think, is quite important in terms of our future explorations. We can see that there is restricted flow from this main corridor here to Newby Choke Rising. And we can also see restricted flow, the dotted line down to this major conduit here, as we would see. So water is managing to cross, if you like, fault barriers and so forth, but probably not at the rate that we first thought. So this does tell us an awful lot about hydrology, but we have a lot more to understand. And Hernal Ridge Sink, for those who know this area well, is much lower down from this bench and is in a Newby Choke valley, which is, we believe, a dry valley, not a meltwater channel. So that again gives indications of what could be there. So what does this tell us about our speculative cave pothole on Newby Moss? So here we are. Here is Longkin West, which we've talked about. Many people are digging and have reached quite a formidable depth here, but I still haven't reached the master cave. But we believe it can't be much further below. Again, this is speculative, pillar holes, fluted holes. And here we have a 2K distance between this. At this end, we have a very large dolin that people will probably know about at the top of Clapdale. And this is a very old feature. It's pre-Devensian, we believe. So this would have been part of a cave that could have been developed as much as 1.3 million years ago. Most of these caves that we talk about in the Yorkshire Dales are far younger than that. But this is showing you something about how long some of these relic caves could have existed. And here we have a speculative argument about cat holes, a semic-phreatic overflow passage from Moses Well, but we have a problem of water meeting a roof and making it impenetrable. Here again we have Moses Well, and again this cave, although it doesn't suggest it on this diagram, is impenetrable because of its very low passages. So as we move forward, this is just a slide, Google Earth of the Hernal Moss area just above Newby Moss Cave. I've put this in because it does show you how the fault here, the Hernal Moss fault, is directing a certain amount of potential here for cave passage to go down towards Clapham Beck Head, and also with a restricted flow towards Hernal Moss, to Moses Well, sorry. And we've worked on this cave now and reached a conclusion, but we've looked at other ones here. Craven Pothole Club took that one off us, but we've looked at Strawberry Pot as well, a new dig here. So we try and use the indication of the fault to understand where we might go next. And how do we get into this master cave? Well, Moses Well, it was first penetrated by cavers back in the 1950s by the BSA, a very old club in the Yorkshire Dales, but they gave up because it was hard work and it's on important land in this area, and it needs just explosive to manage to get any further. But who knows, the passages that lead to the master cave could just be around the corner. And here's a slide of Moses Well. Here, as I said, you can't get any further than that at the moment. John Cordingley, a colleague, produced this slide, and it's this survey, and it's been redrawn. And as you can see, it gets extremely low and unreasonable at this point here on the survey. And then cat holes, that's the overhead overflow for Moses Well. We think perhaps that could be the way in. If we look at the survey for Moses Well, for cat holes, we can see here that on the plan, it says survey continued. This is a very old survey that was originally done by someone called Bob Leakey, a famous explorer of caves in these regions. many, many years ago, and this does really need a new survey. But it's possible that it could go beyond there. This cave is very flood prone, very dangerous in that respect. So to go further, I'm sure will require chemical persuasion with explosives, but who knows, this could be an access to the Newby Moss Master Cave. And there again, just to remind you, we were just talking about this conduit here that's currently blocked. Divers haven't made any impression on it because of the nature of the cave being very unreasonable. And finally, just acknowledgements to people involved in this. My son, who did nearly all the research and the slides and the maps and the images. People at Hull University, Jonathan Dean there, who were working with him. Philip Farrer, the landowner of the Ingleborough estate, who gave us permission to test the sinkholes on the fell, and was very supportive in what we did. Natural England, because the area is a triple SI and is very sensitive. And I would remind you that the fluorescein is not a contaminant that would do any danger to the area. So it was important to get their permission. And also North Yorkshire Environmental Health Services were happy as well with the amounts of fluorescein that we were using. And then finally, the BCRA, who always provide advice and support to these types of research. So that's it really. Thank you very much. As we go back to that slide with that beautiful picture of Ingleborough on there. So really it's back to Alina, who will filter the questions.
Thank you very much, Jed. It was very nice and very complex information about the area from all points of view, geological, geomorphological, hydrological, and hydrochemistry also. So it's really, really complex, like I said. We have in a chat 2 questions of the Padlet. Please feel free to write a question if you are interested in something. I'm putting the link again, but there are coming new questions. So only very short. So the first question is from Miriama. I would like to ask how many women have been working on searching, digging through this lost river? Thank you for your answer.
How many women?
Yeah.
Well, I certainly know a number of women. There haven't been too many women in our particular team, but there is a number of women certainly working on Lonkin West I know about. I won't mention a name or their names because I don't want to embarrass them, but obviously women are involved in this project. And the sump that I mentioned, the siphon in Newby Moss Cave, was last dived by a female plongée, a female diver, who managed to get to 50 meters in horizontal length. So the woman on that particular small expedition was the main person doing the cave pushing and exploration. So yes, we have many women cavers and explorers and divers involved. Thank you.
See, in the present time, it's very important to have also men and also women in such action, you know, yeah, from a different field of the work and so on. Okay, thank you very much. We have another question which I copied from a YouTube chat. Do you think that a large, enough large sinkhole usually indicates a cave? Or is it something that originates at least an underground flow system?
Yeah, if I fully understand that, that's an interesting question. I mean, people will have been watching and thinking, well, come on, that water's just sinking and going into a very immature series of passages that cavers will never be able to enter because of the nature of the way in which the water is dissolved into the limestone below. It could be that we're dealing with very immature and small passages. And some people have said, well, is it, you know, this would be the barrier for further exploration. Some people have said that perhaps on that particular area of Newby Moss, there were glaciers there just slowly at a subglacial level, just injecting water into the carbonate at very slow levels, which would have meant there wasn't masses of development through those melting streams, just gradual, fairly, you know, long time melting. So some people are skeptical about whether there is something there. The only thing I would say is we know there are major faults under Newby Moss, so there are opportunities to break into these faults, whether they are large, small. And after all, there is, in terms of measurement, enough water flowing into the systems to suggest a large collector. Yes, it isn't as big as that which we find in Gaping Gill, for example, but we still believe it's worth looking for. Does that answer the question, or is that probably not an answer? Okay.
I think the question, the answer was good for this. We have next 3 questions which are coming already into the chat of the Padlet. How do you know that cave passage is responsible for the connection between the sinks and the resurgences shown by the tracing studies? And how do we know that the water isn't transmitted through the karst solely via pores and joints?
Yeah, okay. We partly know that because of the allogenic nature of the caves in the Yorkshire Dales. We know they are mostly very fast throughput systems. They go in at the shale margin, and they obviously emerge at the resurgences. So we're working very much on an allogenic model here, more than a autogenic model that you would probably find in other areas of the UK. For example, in the Mendip Hills in Somerset, autogenic recharge is far more important than allogenic recharge. Now, more knowledgeable geologists and hydrologists would probably ask me more questions about that. But that's really the basis of what we're thinking. On what we know about the nature of sinkholes and potholes in the Yorkshire Dales, we have learnt over many, many years how we believe they operate in terms of their regimes. So all we can do is go on that basis. But we're not discounting lots of autogenic recharge in these caves as well. But we think the autogenic recharge does obviously play an important role in the more important allogenic. Thank you. Yeah. Does that help, or is that?
I'm sure that the situation in your karst area and the model of it are you working with? So it's very important information. Another question is first, thank you for interesting talk. Did you use different dye tracers as well as Fluorescein? If not, how did you confirm that the results were not delayed dye from a previous test in another sink?
Okay, I was hoping nobody would ask that question because that does put holes in some of the research that we've conducted. There's a number of things here I could have talked about, the limitations of what we were doing. We used principally this artificial trace of fluorescein because we wanted to be consistent. But there is a problem in terms of how long a trace like fluorescein can be in residence in a cave. We know this. It doesn't automatically flow through very quickly, depending on the conditions at the time. It can stay within time in caves, and it can exit caves at a later stage, which would obviously create problems for the next test. So this is something that we were worried about, and we did have to conduct this research over a relatively short period of time, really, because of the permit that we had from Natural England and from the landowner. So yes, there are problems there. So to try and combat that, we did develop a rainfall chart that John Cordingley, again, one of my colleagues, actually gave us, and we did try to remain faithful to that in terms of input and output of the cave. But it is a problem, yeah. And while we're on that, I mean, the other issue was, did we always use background fluorocaptors in the cave? So in other words, before you even put the fluorescein in, you need to know the composition and the nature of the water that you're looking at. There are many, many different organic materials that are very close in terms of wavelength to the sodium fluorescein itself. And only when you look on a fluorospectrometer would you be able to see these differences. So we didn't have the benefit of a fluorospectrometer for a lot of these tests because of the start of the pandemic, actually, and the problems of laboratory analysis. But yes, there are concerns there about the scheduling of the tests, and that's a very important point.
Okay.
Does that help? Or?
I hope everyone is satisfied with your question. The another question is, again, great talk, Jed, first. And the question is if you can talk to the observed transmit time for the flow tracing tests relative to allogenic recharge.
Yeah. Again, very interesting, and this particular research didn't take account of the flow times. This is something that really does need to be done, and some of the tests that were done outside of this research on Lonkin West, for example, didn't give indications of flow times, and in those days it often relied upon some poor soul sitting at the cave resurgence waiting for the green coloration to come through. But we weren't able to do this. We weren't able to use large amounts of fluorescein, and there wasn't anybody that was around to be able to sit there and wait for the flow to come out. So it's what we need to do next, really. And teams that are have more sophisticated equipment than us need to start doing things like that. And certainly that's something that we would do next time. And Aaron, my son, did want to do that, but unfortunately it was more complicated and required a lot more sophistication. But it is important to understand the flow times. And is the water not flowing through quickly because of restrictive passages, or is it flowing through very slowly because there are many sinuous passages of this massive master cave that we want to get into? So interesting, yeah.
So the main point is to find the recharge area, also not to know how quickly the water is going through.
Yeah. Yes.
Okay. So it is also the next questions which are which is connecting to this. If you would choose one finding during the research, which one was for you the most interesting and surprising?
Well, first of all, the most exciting, I think those sinkholes, high up at pillar holes, fluted fluted hole, sorry. That was very important, I think. And to me, the fact that we had thought that the faults might have had a big influence upon the direction of the cave development. So that was very exciting, really, and quite surprising. I think that one, yes, that was. And it really did concentrate our minds on what we needed to do to try and make this project more possible. And it's very easy to get fed up and think, well, you know, we've been working on this fell for so many years. We need to move on. Personally, I have moved on a little bit to other areas like Fountains Fell and things like that, but I'm still very committed to going back to Newby Moss with members of my club. But it was very exciting to find out the direction of the hydrology, I think, as we understand it.
Yeah, very important. Okay, that were all questions from the Padlet, but I saw one question in the chat of the YouTube channel from Joshua Marshall. Kevin Dixon, a part of the BPS, has done an extensive research on the gaping well system. he seems to think there is a high difference between the sump in a gaping gill compared to the sump in the Ingleborough show cave, indicating dry passages and a possible waterfall. Does that tie in with your research?
I'm no expert on gaping gill. I must have, there are others that could probably answer that question far more thoroughly than myself. It's very interesting to hear that of all this research that has been done in gaping gill. I'd be interested to obviously look at that. But we do know, as I say, from the research we looked at there, are restricted flows, certainly from water going towards gaping Clapham Head, from the Hernal Moss side of things. Newby Moss Cave that we looked at in some relative detail there is very close to that Hernal Moss pot total depth. So we do believe there are many influences in terms of the faulting and the hydrology in that area northeast of Newby Moss. But again, I can't answer the questions of gaping gill, unfortunately. Thank you.
Thank you very much. That was the last question from our chat and from Padlet website. So I would like to thank you very much for your time and for this very interesting presentation. The beginning was not easy, but we managed it somehow to do it. I would like to make some small advertisement for our next presentation, which will be on the 21st of April at the same time, but without technical problems probably, at 6 p.m. Central European time. And my main guest will be Karol Kiszka. He's a caver who is very active in many cave diving projects of Slovakia and also Sardinia and Mexico. And he will be talking about the underwater research of caves of Quintana Roo region of Yucatan in Mexico. So you are I will be happy when you can join. Information about it you will find on this Košice Geography channel and also on the Facebook in next days. So once more, thank you very much. If you want to tell something more, Jed, you have the possibility now.
Oh, crikey. Well, I just say thank you to everybody for being interested. It's great to be able to share this sort of thing with the many other fellow speleos and even people who don't know anything about caving that I know may have joined this webinar. And I must say thank you for Alina, because she really pushed me to do this. It's so easy not to do things, isn't it? Yet she said, look, you've really got to come up and do something about this as the president of the FSE. So thank you for putting me through the pain and tribulations of doing it. And thank you to my assistant here, Imogen, for helping me with the technology that I don't understand. Without her and Alina's helpers, it would have been impossible. Thank you. So thank you very much.
Imogen is very happy for this advertisement for her person. Thank you very much once more. I wish you a very nice evening, and I hope we will see us in the next time on the next presentation again. So stay healthy and nice Easter days.
Thank you. Yeah. Okay, bye-bye then. Bye, everyone. Bye.